everyone. I'm Colleen Stover with the Space Policy Show. Today is episode 106. It's all about space safety. We've got a lot of interesting people lined up that are going to be making some comments, but today's discussion is going to actually be led by Samira Patel from the Center for Space Policy and Strategy. She's returning to the show. And she's going to be talking to Josef Koller. He is co-founder of Aerospace's Space Safety Institute. He's also with the Center for Space Policy and Strategy. We've also got on the line in a little bit Uma Bergman. She is current lead of the Institute for Aerospace, and she'll be making some comments about the Institute. So let's just go ahead and get started and go over to Samira and Josef. Guys, take it away.
Thank you, Colleen. Hello, everybody. I'm Samira Patel here with Josef Koller, and I'm excited to announce the launch of Aerospace's first ever Space Safety Compendium. The Space Safety Compendium has been published by Aerospace's very own Space Safety Institute and covers subjects across the Institute's 5 different mission areas: Space Situational Awareness, or SSA, Space Operations Assurance, Launch and Reentry of Spacecraft, Cyber and Spectrum Concerns, and Human Spaceflight. The compendium also offers a chapter on cross-cutting issues, acknowledging that these issues don't work on their own, rather they're like a Rubik's Cube, where each mission area must effectively align to create a safe environment for operations in space. And each of these mission areas is intertwined with overarching space concerns that are ultimately people concerns. So the compendium also examines questions of workforce development and norms of behavior in space. The compendium incorporates policy papers, science papers, studies, and presentations developed by various subject matter experts across all mission areas at Aerospace. It also offers some recommendations for how to address some of the key space safety challenges we've explored. The Space Safety Compendium has been produced by the Institute, SSI for short, which Aerospace established to lead on space safety-related subjects. As I said, I'm here with Josef Koller, who co-founded the Institute and co-leads it with Uma Bergman, who would like to share a few words on its background.
Space safety is very key and relevant in today's environment. The space enterprise as a whole has undergone unprecedented growth and transformation. We've seen a shift in the model where the government led space activities, and now we see a new model which is led by commercial spaceflight. We've also seen an increase in the size and the number of constellations being launched, and this introduces challenges for space traffic management and debris management, and introduces uncertainty into collision avoidance. What once was a dream, a concept, space tourism, is now a reality. We've seen historic, amazing human spaceflight missions in the past few years, and that introduces an element of human spaceflight safety into the equation. The scope of what's possible in space and the number of parties trying to achieve that has also started expanding. I'm talking about things like mining, pharmaceuticals, in-space robotics. These are all new types of space applications. The number of international participants has also started going up. There are many, many more spacefaring nations now, and there are also international individual actors. So as a whole, we see a lot more new actors in space, and they have varying degrees of knowledge when it comes to space safety. So Aerospace decided that we need a whole of space approach to space safety. And that's why we established the Aerospace Space Safety Institute to study, analyze, educate, and promote how to make space safer and bring our knowledge and services to the community.
As Uma has said, space is rapidly changing, and 2021 was a real turning point, particularly for space tourism. We saw commercial spaceflight really taking off, with Virgin Galactic, Blue Origin, and SpaceX all completing multiple suborbital space flights. In 2021, 30 tourists went into space, which is the most ever. In fact, the space tourism market is expected to grow by $2.5 billion by 2031. We can also expect to see more launches every year, And while there are only 15 launches in 2015, by just 2025, the Federal Aviation Administration expects there to be about 266 launches per year. At the same time, we have more space debris than ever, and only 27,000 pieces are currently tracked. We haven't been able to track many pieces that are sized a centimeter or less, for example. However, debris travels at incredibly high speeds of about 17,500 miles per hour in low Earth orbit. So even the smallest piece has a big impact. The Space Safety Compendium discusses many of these challenges in more depth, but before we can go into findings and recommendations, I wanted to turn it over to Josef, if you want to tell us a little bit more about the Space Safety Institute.
Hi, Samira. Yeah, thank you so much for having me. I'm really excited to introduce the Space Safety Compendium to the audience here. To us, the Space Safety Institute, like Uma and you explained earlier, was really the reason to looking at the economic and the space economics and the tremendous change that we're seeing in how people are operating in space. But at the same time, it's also still very risky and still very, very costly as well. And so how do you combine all these things together in a safe manner? Because if I may use an analogy real quick, it's like having a traffic accident in the middle of a city, but if you might get a traffic jam or so forth, and traffic might slow down, but it's really just affecting the inner city. In space, it's really very, very different, right? Space is an international domain. It's a multi-actor domain. It will quickly affect everybody else who's a space actor. And so we were really looking for a more holistic approach to spaceflight safety, including all the various different actors. And we're going to talk about those more specifically here next, because that holistic approach really is what we need to make space operations more safer. And in the end, we'll be all better, safer off.
Thanks, Josef, which brings us back to the compendium. As we discussed earlier, it covers critical decisions and recommendations in a broad range of topics within SSI's 5 mission areas. So let's start with SSA and space operations assurance. Aerospace expert Marlon Sorge will share some of the high-level issues we're dealing with when it comes to SSA and space operations.
Rapid changes in space activity in the last few years are forcing reconsideration of how to approach space safety, requiring a number of changes in space situational awareness, or SSA, and space operations. These changes include, for example, large constellations, where now we have sets of thousands of satellites in orbit, which has hugely increased the amount of traffic of the active satellites. There are also many more operators recently, which means there's a whole other difficulty in terms of communicating between them for things like collision avoidance, as well as a much wider range of skill sets in terms of levels of capability of the operators. And additionally, there are a whole sets of new missions, things like rendezvous and proximity operations and active debris removal, that have added to a whole other set of requirements for what's needed in terms of space safety. And all of these changes and more are causing significant challenges both in SSA and space operations. And for SSA, what we really need a more holistic approach. We need to be able to pull in the many new data sources that there are and make sure that it's possible to monitor the new environment and all the new activity that's going on. Space operations, there needs to be a lot more effort and coordination with many new operators and many, many new operational satellites. And not just the practice of the operations themselves, but the best practices that we use to do the operations. We really need to focus on performance-based approaches to best practices. The speed that the technologies are changing will outpace any really specific rules very, very quickly. And finally, we need to promote debris mitigation and good following of those best practices, because as more and more traffic increases, it becomes more and more critical in order to control the environment. And most importantly, we need to start on this and get ahead of the problems before things get too difficult.
I think Marlon mentioned some important recommendations, but Joseph, I wanted to ask you maybe to help us distinguish SSA from space operations assurance, particularly space traffic management, or STM, which is usually considered a space operations issue, assurance issue. As you know, the distinction between SSA and, say, STM isn't so clear.
Yeah, that's right, Samira. That's really a good question. A lot of people have a very similar question. And to me, space situational awareness, or SSA, is really the foundation of everything that we know about what's going on in space, near Earth orbit, up to geo and even cislunar. It's having detailed knowledge of the objects. It's having detailed knowledge of what their maneuver plans are, what their orbits are, and so forth. There's actually a slightly different but very similar term out there called space domain awareness. So some people use that term a lot as well. And look, every nation almost has their own definition of what SSA is, what's included, what's not included, and so forth. But so for the general sense is about having detailed knowledge of what's going on in space. So, and that's really the foundation, right? You need that detailed knowledge to do maneuver planning, to plan your orbits and your missions and so forth. The next level up from that is then that space traffic management. And like Marlon said, that's so important with all the new large constellations, large LEO constellations coming up. And it's that deconflicting of maneuvering, deconflicting of orbits and so forth. And it's something that we don't do very well today, right? In many decades ago, space was pretty much go and do whatever you want to do in terms of which orbit you want to go into. The Outer Space Treaty just provides some very simple restrictions, but not really much more than that. But with the number of actors going into space, the number of objects, like Marlon said, a tremendous increase of objects in space, we need to be able to deconflict, right? And so that's the term of space traffic management. It doesn't mean that you or a particular entity is directing the traffic, but also includes providing conjunction analysis and advisory notices and so forth. It doesn't mean there is control, right? But management includes all the varieties of different information exchange that needs to happen in order to operate safely in space.
And I think that includes getting, for example, information from owner operators, getting data from them, because as we see more of these satellites that are able to actively maneuver in different orbits, it's not going to be just trying to predict what orbits they're in and they'll be in, but also how will they maneuver in the future. And I think that will also, of course, have huge implications for how space traffic management systems are done. And being able to actively leverage that data in real time and see those orbits change in real time.
That's right. I mean, a few years ago, it was not very common for satellites to have propulsive maneuverability on board, or have detailed knowledge of what their orbit is or their position along the orbit. Now, commercial space is drastically, and innovation is drastically changing that. It allows us to have more maneuverability, more capability on board, and very detailed knowledge of where the objects are at any given point in time. And that lets us really do that piece of space traffic management that we would not have been able to do a few years ago.
Yeah, and I mean, that also has a lot of implications for active debris removal, for example, which is a huge space operations assurance issue. Joseph, I don't know if you want to expand a little bit more about ADR.
Yeah, ADR, or like you said, active debris removal, is one of the components that by removing debris and essentially making operations safer in outer space. The more traditional method is, of course, to re-enter or deorbit your objects, but sometimes that's not possible, right, for various reasons. And so one way of so to say flatten the curve of space debris and the number of objects in outer space is to also do active debris removal. Now, in the compendium, people can read that it's very important to have a good common understanding of what that actually means. And that there is a contractual understanding in place of ownership and consent. Can I remove somebody's debris? Did I get permission from that owner to remove debris? And in addition, to also provide that regulatory oversight, right? According to the Outer Space Treaty, commercial activities are required to be authorized and to be continuously supervised. So all that must be consistent. And there are several companies now working on that, and I think we're making progress. And I think that's the second biggest piece in order to maintain the orbit safety, so to speak, by using, in addition to deorbit, also use active debris removal.
I think that's a great place to transition to launch and reentry. We also have a video of Rob Unverzagt, who is a specialist on launch and reentry, to talk a little bit about the high-level issues we're dealing with when it comes to those challenges.
Hi, everybody. Today I wanted to cover a topic we cover in our Space Safety Compendium involving launch and reentry. These areas are particularly interesting because they have the potential to affect the general public, not just other space operators. For launch sites are generally located on the coasts. For example, Cape Canaveral Space Force Station, Vandenberg Space Force Station. Launch trajectories fly out over the water, limiting the effect of people living on land. However, it can affect, for example, aircraft. The way that risk is mitigated is by cordoning off large chunks of the national airspace system, tens of thousands of square miles from sea level on up. Aircraft are warned not to enter this area for some amount of time, and that time is determined by the launch window for the launch under consideration. Now, that's burdensome, but it's executable at, for example, previously historical launch rates. Before very recently, from Cape Canaveral, for example, there were maybe 20 launches a year, so 2 a month-ish. So that kind of thing gets in the way, yes. It's a pain, but it's executable. For very recently, that launch rate has increased, and it is projected that launch rate could increase substantially, driven by, to a large extent, commercial large low Earth orbit satellite constellations, potentially into the 120 launches a year. Now, that kind of methodology of cordoning off airspace would become quite burdensome. So looking ahead to how the launch risk can be mitigated, we make some recommendations in our Space Safety Compendium, which recommends not so much accommodating launch into the national airspace system, but integrating it into the national airspace system. Specific recommendations are listed in the compendium. Please read it. Going into situational awareness, data sharing, policies, et cetera, et cetera. The other area, reentry, also has the ability or the potential to affect the general public. Until recently, historically, the usual way of disposing of satellites is to let them re-enter the Earth's atmosphere, where it has been assumed they would burn up and not pose a risk. However, we know that re-entering rocket bodies, spent rocket bodies from delivering satellites to orbit, and satellites that have reached the end of their useful life, when they re-enter, oftentimes debris reaches the ground. In fact, a woman in St. Louis several years ago was actually struck by a piece of re-entering space debris. She wasn't hurt, but she was hit. Now, given that and this potential to launch large low Earth orbit constellations, which will increase the number of decommissioned satellites re-entering. For example, a lot of these constellations could add tens of thousands of satellites on orbit, resulting in hundreds and thousands, perhaps 1,000 re-entering every year, which is significantly larger than currently. So in order to mitigate that risk, we make several recommendations in the Space Safety Compendium, one of which is essentially, it's called design for demise. Ensure that satellites, when they are designed, can break up and form harmless pieces as they re-enter the atmosphere. Another recommendation is to actually target deorbits, not let them randomly re-enter the Earth's atmosphere, where they could land anywhere in their flight path, but actually target the broad ocean area for decommissioning, for these decommissioned satellites. All of this is covered in our Space Safety Compendium. I urge you to read it. And in particular, given that these launch and reentry risks pose a risk to the general public, the uninvolved public, it's all the more critical that these areas get addressed.
I think Rob made some really interesting points, and I think he specifically pointed out the impacts that launch and reentry especially have on the general public, on how people on the ground or people in airplanes especially are impacted. I think an aerospace assessment at one point showed that there's an estimate of a casualty of 1 every 10 years by improper reentry. And this was done before another 85,000 satellites were proposed to go up into space. So there's quite a lot in terms of the impacts. I think, Joseph, it would be interesting to hear what your thoughts are on some of the things that Rob said, and like some of the recommendations that you see for improving this public safety.
Yeah, that's right. So it was part of the issue that we see. I mean, Rob highlighted, and just like you said, really highlighted the tremendous change that's going on in the launch industry just by itself. 20 years ago, how many commercial launch companies did we have, right? And so the environment, the launch provider environment is really changing dramatically. But what we also see is a variety of different prior safety experience, right? From the very new entrance launch provider to the much more experienced ones. And launch, is very costly and very risky as well. And so it was very important in the Space Safety Institute through this compendium to highlight some of those recommendations, to accommodate at the same time the growth of the space economy. That probably means more launches, but that also increases the potential hazards that somebody could experience, even on the uninvolved public, right? The general public, like Rob pointed out so much. But it's also about shrinking those launch windows. How do you find the right launch window going through all the very, very large constellations that we didn't have a few years ago, in order to grow that space economy, but also ensure the spaceflight safety and the safety of the uninvolved third public on the ground. And so this is just yet another one of those examples, and Rob really very eloquently pointed out what the issues are.
Yeah. I think we'll move on to Lori Gordon, who will share a little bit more about cyber and spectrum challenges next. Lori will talk a little bit about the high-level issues, because we think a lot about cyber and spectrum issues as being terrestrial-based concerns, such as computers being hacked or fiber optic cables for internet. However, these have huge ramifications for the safety of spacecraft as well. So let's turn it over to Lori.
Hello, it's great to talk about some of the critical needs and gaps, as well as opportunities that we're seeing amid the changing dynamics of cybersecurity and spectrum across the space enterprise and across multiple systems within that enterprise. This includes ground network, infrastructure, launch infrastructure, data uplinks, downlinks, all the way to the space vehicle. All of these components are subject to cyber vulnerabilities, cyber attacks, and they all require spectrum needs to produce basic capabilities. So as one cybersecurity challenge, we're seeing with the hacking of low Earth orbit terminals. So it takes a researcher just $25 worth of parts to create a tool that allows custom code to run on the satellite dishes. And This really proves how easy it is for a threat actor to sabotage systems and really create significant safety challenges. So we're also seeing spectrum as a challenge as commercial space launch entities are proliferating and are increasingly involved in the transport of cargo and people into space. And orbital launches are also placing satellites and payloads into space as well. So the allocation of this limited resource spectrum is key to enabling commercial launch, and we know that spectrum sharing and reallocation really needs focus. The government is putting into place more initiatives to reduce risk and increase safety. For example, NIST is putting into place a cybersecurity framework profile for hybrid satellite networks. Congress is pushing legislation that would require Space Force to establish satellite protection requirements before starting any new major acquisition program. Even non-traditional space agencies are establishing space cyber protections. For example, Homeland Security just released their space policy that's heavily focused on space cyber. In addition to the government working these challenges, there are several significant initiatives that the commercial sector can focus on that they are doing right now to shore up cyber and spectrum opportunities. So this includes properly funding the identification and implementation of best practices, establishing requirements to guide next-gen platforms, ensuring the approach defense in depth, intrusion detection and prevention applications, managing supply chain risk, and then specifically for spectrum, doing a cost benefit of spectrum sharing and reallocation, and then also ensuring that space systems are designed to be responsive to spectrum changes. So there's lots more in the compendium that further describes how to implement each of these recommendations, and I hope you join me in looking forward to a safer, more secure future by adhering to and helping to implement some of these recommendations. Thank you.
I think Lori did a really good job of explaining the full gamut of recommendations and how they apply to the full life cycle of a space system, especially given the changing landscape of threats, such as everything from natural disasters, COVID, geopolitics can impact supply chains for spacecraft parts, for example, and even how spectrum is coordinated. So I think there's a lot to unpack with cyber and spectrum that people don't realize have huge implications for how space is managed and the safety of space. Joseph, it would be great to hear a little bit more about your thoughts on what Lori said as well.
Yeah, Lori did really a great job in highlighting I think to me, there are three key ingredients, and it's the three participants, the three actors, or, large dominant actors, governments and commercial sectors, right? And the private industry. And so when we looked at standing up the Space Safety Institute, it quickly came to light that we can look at launch, reentry, SSA, and SDM like we talked about earlier, but it's almost like a Rubik's Cube, right? If you're trying to fix the safety or the color on one side of your Rubik's Cube, it will quickly affect others as well. And so if we don't integrate cyber security and spectrum allocations, all of that, into a more holistic approach on safety, we're missing something, right? And so it's really important that cybersecurity, spectrum allocations are part of it too, because a cyber incident might affect how you take SSA measurements, or that might then in return affect your launch window or your reentry or human spaceflight safety. And so it's really a key ingredient in safe operations in outer space. And so it was very important to have that included in our focus areas.
Yeah, I agree. I think, it's a very implicit but should be explicit concern. And that's why we gave it a huge space in the compendium. I wanted to move on to human spaceflight. Angie Buckley will share some high-level issues about human spaceflight.
Greetings, and thank you for joining our program on space safety. The United States is transforming the way we operate in space. and in particular, the nature of crewed missions. This is changing from a situation that has been the exclusive remit of NASA to a pursuit involving both the government and private industry. We've already seen suborbital commercial space flights that take off and land from the same location. We've also seen commercial missions to low Earth orbit, including a visit to the International Space Station. In the coming decade or so, hopefully, we'll see NASA crewed missions to the moon, commercial crewed missions to the moon, and commercial point-to-point missions for high-speed, long-distance transportation. As the enterprise evolves, the United States government must ensure the implementation of well-defined, not overly restrictive, and timely commercial crewed spaceflight regulations. These might include new approaches to mishap investigation and revising the legislative language in the NASA Authorization Act of 2005 to better integrate the current environment. New performance-based regulations based on the safety case methodology to provide a flexible approach for operators. A future-proof safety framework focusing on people, safety culture, and data collection and analytics, as well as a reassessment of current space rescue efforts and policies that accommodate a multi-vehicle, multi-orbit operating environment to proactively incorporate in-space rescue into the planning. We offer 6 specific recommendations in the recently released Space Safety Compendium. These recommendations include updating human spaceflight mishap investigation requirements, implementation of a safety case approach to commercial human spaceflight, developing and implementing a future-proof safety framework, in-space rescue capabilities, the use of common docking systems, and the integration of rescue plans into the launch planning. For more details on this crucial element of human spaceflight, download the compendium. Thank you for taking the time to join us.
I think Angie did a good job explaining what the different types of human spaceflight are up and coming, especially in commercial spaceflight. We're going to see point-to-point, suborbital, and various other ones. And I think it'll be important to see how the Federal Aviation Administration handles commercial spaceflight and the government writ large as one of the mission areas that we are dealing with at the Space Safety Institute. One of the things that we're considering is how will the government deal with this once the moratorium on regulating spaceflight is potentially nearing its end. And the moratorium, Josef, if you want to tell us a little bit more about it, is meant to end October 2023.
Right. Like you said, it's scheduled to sunset very soon here. And eventually, we don't know yet if it's going to be extended or not. That will be probably immense discussions over the next few months. But eventually it is going to expire. And with the Space Safety Institute, we've done a very careful analysis and a detailed study. We looked at different cases of transportation mechanisms, cruise shipping and commercial aviation, of course, and autonomous vehicles. And we came to the conclusion, like Angie said, we need to step back. We need to step back instead of trying to find what is the next regulation for the best landing gear, right? We need to step back and focus on what do all the different means of going into space have in common. And we came to the conclusion it's people, culture, safety culture, and collecting the information and doing analytics on it. That's really common across all different transportation sectors or industry sectors that have a strong safety need. And so that's very important. But what's really, I think we need to also have a discussion on is that what Angie brought up, the in-space rescue, right? Just imagine an Inspiration 4 mission or Apollo 13 mission gone wrong in such a way that you can still talk to the spaceflight participants, but they have no way of returning to Earth. How do you rescue them? And what's mind-boggling is we don't have a strategy in place. There is no strategy in place today. So I think that's going to be really important that we have that conversation, that we develop that strategy. because it's probably more likely to be a commercial mission that will need rescue rather than a government mission. So I think I'm glad that we have this recommendation in the compendium amongst a number of other ones, but I think those are some of the key ones I think we need to focus on.
And I think as we see more and more space flight and more tourists in space, right now, for example, when we talk about the mishap investigation requirement, it's managed by the FAA has a requirement for investigating if something happens in space, if there's a serious injury or fatality. The National Space Traffic Board also has a requirement. The NASA Authorization Act has a requirement, but none of it actually specifies what to do in the case of a commercial, when something happens in the case of a commercial flight. So I think that'll become key to kind of define what it means when we have these new areas, mission areas coming up as well.
Yeah, and we know an accident is going to happen sooner or later at one point, right? Nothing
Exactly.
is 100% foolproof. So it's the matter of putting the right subject matter experts in place, so the accident can be analyzed. But our finding was that instead of looking just at accident investigation, which are retroactive, we need to look at predictive and proactive safety. Right. And so going back to people, the safety culture, and collecting data and doing analytics on it, I think are more future-proof than looking at accidents and how we investigate accidents.
And we see in other when we analyzed other transportation industries and leisure industries, that a lot of them have safety management systems in place, and looking at those. Looking at how to proactively build those systems. And then finally, as we near the end of this time on the Space Policy Show, I wanted to focus a little bit on cross-cutting issues, because as we said earlier in the show, a lot of space issues are people issues. And as Josef brought up when we talked about human spaceflight, safety culture, people in space are key core to building a good safety culture. And so I wanted to talk a little bit more about how we think about norms of behavior in space, as well as workforce development issues. Josef, did you want to share a little bit about the recommendations we have?
Yeah, of course. So we chose these focus or mission areas, like we've talked about SSA and space traffic management, human spaceflight safety, and cyber, and so forth. But there are other areas that truly cut across all of them, which is workforce development. We got to have the people, right? And diversity, equity, inclusion are yet another big component there that I think will help us really create this holistic approach to spaceflight safety. And so in one of the chapters in the Space Safety Compendium, we highlight some of the initiatives that we've been undertaking and some of the past learnings that we can maybe apply to spaceflight safety as well. And this was really important to the Space Safety Institute because if I may just summarize the three main activities that the Space Safety Institute wants to pursue, is one of them is the educating the next generation of space safety experts, right? And it's a very people-centric focus term. And I think without focusing on that people component, a lot of the safety understandings cannot be developed. And so people are really at the center, because it's the people who make mistakes, right? It's not the organization. It's an individual, or it's a decision, but it's people who make mistakes. But people need to have the framework and the foundation to be able to not let them accumulate into disaster. And those are really the key issues. So people are at the core and at the center.
Yeah, and I mean, speaking of some of the initiatives that Aerospace has been working on, one of them is Aerospace, and 29 other space companies have agreed to a Space Workforce 2030 pledge, which commits to boosting K through 12 STEM programs to improve the number of women and employees from underrepresented groups are employed in the space industry. Joseph, you mentioned workforce development. What are the other two SSI platforms that?
Right, workforce development and educating the next generation of space safety experts is one of the three main components or main activities of the Space Safety Institute. The other two are providing a platform, a collaborative platform where experts can get together and develop those best practices, like you mentioned, the best practices, the standards. And the other component is to use the deep technical expertise that exists not just at Aerospace, but at a variety of other places, and bring that deep technical expertise to bear and provide independent assessments to the customers and those who need it, right? And that can be international entities, that can be government agencies, that can be commercial entities alike, right? So these are the three main activities that the Space Safety Institute wants to pursue: education, developing best practices in that collaborative platform, and the deep technical independent analysis.
Thank you, Joseph. I think the SSI is doing some great work, and I hope everyone checks out the Space Safety Compendium. If you have anything else, last words you want to add, Joseph, that would be great.
Yeah, really appreciate it. And thanks for all your work in putting the Space Safety Compendium together. I hope everybody will be able to check it out. And thanks for having me.
Back over to you, Colleen.
Wow, thank you very much, Samira and Joseph. And as they were saying, everyone, definitely go to aerospace.org/SSI. You can find the compendium there and a lot of other information about what the Institute is doing and where they're really leaning forward in terms of space safety across the board. You know, Joseph talked about the Rubik's Cube and how if you try to fix spectrum and cyber on one side, that as you're doing it, you can mess up other sides of safety. So I hope everyone takes that to heart. I really like that example that he gave. It was really good. So you can also go to the CSPS website. You can subscribe to our newsletter, like our podcasts, watch our videos, YouTube, all of that. We've got it all, as you know. And thank you to James Liggins, our wonderful technical director, and we'll see you guys next time. Thank you.